Thank you for joining me, Bilge, today for a discussion of AI at Enterprise DB. So let's start first with tell me and tell the audience a little bit about yourself and how you got into AI.
Marc, thanks a lot for the invitation, actually, and thanks a lot for the opportunity as well. I'm Bilge. I'm working as a machine learning engineer in EDB, and how I got into AI is a little bit way back of history. Like back in 2010, 2011, I was it's 13 years ago, right? I was a student for a bachelor degree in computer science. And during that time, I did my internship in a national research center, and I met with text-to-speech concept in there for the first time. And immediately I'm intrigued and my interest got evolved. Hence, I developed an iPhone application. It was iPhone 4 back then. And the app was for visually impaired people so that they can do shopping, basically. It was leveraging the text-to-speech approach. And after I graduated, my interest got only grown. And during my master and later PhD, it increased over time. Since then, I've been in this field and witnessed its transformation from almost only academic to industry level, production level.
So, Bilge, you already touched on that in your answer to the prior question, where you said AI, was something that was much more in the research community. But over the last couple of years, it has really entered the mainstream. Now we're having cybersecurity analysts, linguists, software engineers. Everybody's talking about AI. How come and how did that happen?
Actually, it was back in the couple of years ago, even, it was still almost niche academic interest. But today, it's a central focus on the industry. And at the moment, we are in the midst of a multi-year phase of democratization and commoditization of AI, because there is a pervasive demand driving its integration into various products, especially software technology. And I believe it happened with the rise of foundational models. That models has significantly accelerated this trend by enabling the representation and flexible distribution of vast knowledge and experience. And in EDB, we fully embrace this industry trend by providing the best in database AI as well, and trying to catch up with this industry grade capabilities, AI capabilities as well, to make it more accessible, more seamlessly integrated.
So when you're saying foundational models, is that what many others call LLMs or large language models? What's behind ChatGPT, OpenAI, etc.? So those are the foundational models.
Mm-hmm. There's not only language models, but we may consider when I say foundational models, because today, I think most people in industry are talking about those language models, large language models, when they're mentioning about the foundational models.
Mm-hmm. Okay, all right. So now here we're at EDB. EDB, typically the Postgres company, have been doing Postgres for 20 years now. Are we going to do AI for Postgres, Postgres for AI? Help us understand that.
Okay, it is in both ways, because AI cannot be considered different than the data itself. There is a huge relationship between a strong and powerful model and the data. And the data that needs to be stored, that needs to be delivered in different formats as well, especially real-world data, needs some tweaking, stored in different formats too. So, as we all know, I think you know too, the Stack Overflow had a survey recently, and we have seen that the Postgres has come as the most popular databases. So also many enterprises trust Postgres to store and manage their business data due to its enterprise-grade quality of service, resilience, security, compliance, support, scalability, and performance. So naturally, AI became a natural topic or natural focus for Postgres as well. It is the both ways, AI for both Postgres and Postgres for AI as well.
So you're saying it's tied to Postgres because there's no AI without data.
Exactly.
Right? And so why have the data travel somewhere else? Let's just bring the capability to the data and use it efficiently. So what are the key challenges that EDB is tackling in the AI space?
EDB is focused on creating a top-tier platform to implement AI solutions by utilizing the operational maturity and strengths of Postgres platform. While Postgres provides a strong foundation to us, AI, like especially generative AI, increasingly relies on non-traditional data, which is could be struggle to tackle with for a relational database like Postgres. So it needs to be handled effectively in default. So as a result, one of our primary technical priorities is to enhance Postgres to accommodate new methods of storing, managing large amounts of multimodal data in a disaggregated lakehouse architecture.
Okay. So the world is talking about LLMs, or you call them foundational models. But in Postgres, we're talking about vectors and PG vector. Help me connect those two, please.
Mm-hmm. LLMs have been I think, our focus, or everybody is talking about LLMs because we're communicating through language, and LLMs is the center of language. They're language models. They primarily started as a language models, evolved in time with massive amounts of data to be large language models and neural networks, deep learning as well. So they designed to satisfy such needs as in translation, text generation, summarization. The core component of these models, these LLM models, their ability is to represent words, phrases, or texts as numerical vectors, which we are calling with Postgres, we're connecting them with PG vector. And these vectors have been generated with embedding models. The input, this is text for LLMs, is converted to a multi-dimensional vector using embedding models to capture the semantic meanings and contextual relationship. And I think the best part for me for the vectors that you can use arithmetic operations to understand how close they are together. And the closer they get in the vector space, they're considered to have similar meanings. So Postgres is one of the most used relational database, and it has PG vector. And PG vector has been connecting vector within database for Postgres.
So this with the PG vector allows us to say that, let's say Porsche, Ferrari, Lamborghini, even though the words are very, very different, they're all organized on a scale of cars. They're probably closer to each other than, let's say, a Fiat 500 or a Lada or something like that. So if we're looking for fast cars, we're probably landing in that space where we find Porsche, Lamborghini, Ferrari, and a few others. But other cars, I don't know, Fiat 500, a Topolino, or something, are very far away from that. So vectors allow us to represent these complex semantic things. And I think, as you said, they have this really interesting mathematical property that you can do a lot of the calculations to identify nearness, etc., through matrix multiplication, which are very, very efficient on modern compute systems.
I want to give another example to make it more visual for the people, maybe. The earlier BERT model, for example, we don't even talk about it today. It's an earlier LLM, but it was trained for English text only. But even then, you could map a word of like the English word with French word. You could do that because the vector lets you do that in the vector space. They're closer. So you would understand the car for the English and the translated version of the car for French are close to each other in the space.
Okay, yeah, that makes good sense. So that's why vectors are so central to a lot of the AI processing, both for classification, for generative applications, etc.
Exactly. Yeah.
And Postgres being a multimodal representation system that can do geographic data, texts, etc., it can also handle vectors very, very easily. So we have good platform that we can use to execute those things. Foundational models, or LLMs, they come in many flavors, right? Some are offered as services. So everybody's talking about OpenAI. Everybody's talking about ChatGPT. Hear about Llama from Facebook, etc. Some are offered as services. Some get downloaded. Some are open source. Some are proprietary. Help me figure that space out, please.
Yeah. Oh, let me try that. Okay. We have service-based models, like they're generally closed source, considered closed source, let's say. Like, for example, in ChatGPT, it uses GPT 3.5, GPT-4, GPT-4o, and these could be accessed by a service like an API. You could access them, ask whatever you want to ask, and get the answer. Or, Claude or Google's Gemini. And it is so easy to access to them. And they're convenient, but they could be costly for high volume of use, for example. So they had some limitations. There are also open models that you could download them, run locally on your own service. Like, I think Mistral is a good example to that, those models at least. And these models give you more control, potentially lower costs for high usage, but require really technical expertise and some computational resources. But there's a transparency in there too. Like, for the privacy concerns, you may want to go that path. But there's also a middle ground for the models. Those models have open weight. The model architecture weights are available, but the training code isn't. I think Llama 3.1 is a great example for these type of models. These models allows you to fine-tune, do the deployment flexibly and protect some intellectual property at the same time. Choosing between these options depends on your factors, I think, like control, cost, scalability, and privacy.
Okay, interesting. And for those of you in our audience that are not familiar with Mistral, Mistral is a French company comparable to OpenAI. And I think the Llama model that you mentioned is that's Meta, Facebook, right? Who are publishing that. There are some compliance and proprietary type reasons, right? When we're talking about context that is being sent to the engine to make sure that the engine has is aware of prior answers and potentially a lot of the input that the user has provided. So now we're getting into a space where proprietary information may be sent over to a publicly hosted service like OpenAI, and not everybody may be comfortable with that. Not every situation may be applicable in that situation. So in this context, in this context, I hear about things like context size, fine-tuning, RAG, or retrieval augmented generation. Initially, I heard about fine-tuning, and then RAG came later. So walk us through what that is, and why does that matter?
Mm-hmm. I mean, fine-tuning has been here in the terminology for a while because, even starting with the BERT, even before that, there were pre-trained models where you can do fine-tuning. Fine-tuning is the process, while you do further training of an existing pre-trained LLM model with your specific data, you change permanently the model for your need. Like, for example, a general LLM, let's say we have Mistral or we have GPT, and you want to fine tune it with your, I don't know, law text or medical text to make it more specific or to improve its performance on healthcare related queries, or to make it increase performance for your language specifically. And fine tuning is this process, actually. It's a permanent change. There is retrieval augmented generation. It is also a technique we have, like, I think recently met, like a couple of, maybe 2 years ago, maybe last year. And it was very popular last year. It's a technique that combines the broad knowledge of an LLM with proprietary specific information that is retrieved from a separate database. And it's a way, you don't change the LLM like you do in fine tuning, but it is also a way to give the LLM access to up-to-date or proprietary data that it wasn't trained on initially. And I think we have good examples for those RAG applications in EDB as well, like EDB Envoy, Migration Copilot. There are great examples of a usage of RAG. And you also mentioned about the context size. Context size is basically refers to the amount of text or tokens, let's say, that an LLM can process for once. Like, this limit is important because it affects how much information the model can consider when generating a response.
Okay, so let's drill into that, because token size or token context size is something that really intrigued me initially. So I believe what this means is that if you're asking a specific question, you want to provide more information. For example, you're asking our Envoy onboarding copilot a question, and you'd like to provide more information so that the copilot can give you a very relevant information. Or in our migration copilot, you can send in large chunks of Oracle code and you get a translated version back, right? So that is the context. And when you said token, this context is tokenized first before it's sent. What does that mean?
Token is like, we can consider it like word. When we divide by spaces, you can consider each word as a token. It doesn't have to be in that way. It depends on the model. It is changing. But in the simplest way, you can consider it like that.
Okay. So I would take this whole SQL statement and it gets chunked up into the words, the brackets, the nesting structure, etc. And that is the context, right? And I believe that when I ask several questions and they're part of one dialogue, then the context also includes what we just talked about, right? So that the engine is then aware of the history and the context, right?
Mm-hmm. Sure, yeah. And the context size is important because it affects how much information you can give as a context to the LLM at once.
Mm-hmm. Yeah, okay, good. Thank you. So today you already mentioned we're using AI in at least two customer visible areas. One is EDB Envoy, the onboarding copilot, and the other one is, I think, our migration copilot, where AI helps translate Oracle code into Postgres code. Any views on that, where we are and the history, what's going to come next in those areas?
Mm-hmm. I think we're doing it really, really well, but we're not limited with only EDB Envoy and Migration Copilot as well. We're like developing them so fast, and they're like improving every day. As you mentioned, that they're customer face product that we have in today in EDB, but there's other efforts like we put into the fields. Like, for example, we added PG vector support into private GPT. And at the moment in EDB, as AI team that I'm working on, we're working in a Postgres AI platform that customers can use as well, developers can use as well, because like still AI requires some deep knowledge, but it getting to a point that everybody in, at least in software sector, let's say, demands AI solutions in their product too, but it requires a deep knowledge, as I said before. You can do POC, you can do prototype using AI models, but when you want to deploy something to production, enterprise ready, that leverages AI, let's say, you need more than that. You need more knowledge, more distilled knowledge, actually. And in EDB with Postgres AI, we're combining the proprietary AIDB extension, which we have just released the tech preview version, and the open source PG vector extension to create a consolidated solution for vector storage, similar to Surge, or like, for example, to build RAG applications more efficiently, easily. Like it's the AI application development pipeline for developers, let's say. And we aim to provide the full platform version for our customers for the near future.
Okay, so what's next? You mentioned we're creating this development environment that makes it easier to define the contexts, interact with a foundational model, get answers, use it for search, for generative AI. What comes after that?
I think at the moment we're getting more and more involved into AI space, and like we're widening our action area. And as I said, like we have just released a tech preview that simplifies the integration or preparing or building an AI application easily without requiring any deep knowledge, deep AI knowledge, but also at the same time, without losing the same capability, feature capability, as I say. And we're considering to move forward to that. We want to provide solutions, Postgres for AI and AI for Postgres as well, as you said it.
All right. Well, thank you very much, Bilge. That was very interesting view into what's going on in AI at EDB, and invite all of our audience to take a look at Envoy, which is on our homepage and gives you a really good idea what can be done with Postgres and AI. So, thank you very much.
Thank you for inviting me.